The video core architectures I'm showing in here are a little bit on the simplistic side. For example, if you develop a new video core, this particular architecture doesn't tell me how do I connect it to the whole video system. So let's take this design a little bit further and to improve it so that we can actually plug it in to the system, similar to what we did with the MMIO course. We developed the hardware for the core and then we defined certain ways to actually plug it into the system. I will focus on the pixel generation circuit for now, but the same idea is actually applied to the pixel transformation circuit. So the first improvement we're going to be doing is actually including a slot wrapping circuit. So just as a quick reminder, we have, whenever we developed an I.O. core, we developed the hardware and then we developed some sort of a wrapping circuit. And that wrapping circuit defined very standard signals, and these standard signals allowed us to connect the I.O. core to the MMIO controller in here. Okay, that's what we did. And of course, that's connected to the bus, to the bridge, and then from the bridge in here to the CPU. So we need to do the same exact thing for the video subsystem. So in the video subsystem, I know that the video subsystem has a video controller that's connected to the bus, and the video controller also have some sort of a standard ways to connect a new video core. So whenever you design a new video core, you need to design the hardware like you did with the I.O. core, kind of like what we did in here. And then what you need to do is you need to have some sort of a wrapping circuit, kind of like what we did in here, and that wrapping circuit will be here. And that wrapping circuit will define very standard ways or standard signals that will allow us to connect to the video controller, so it's part of the whole system. But just remember, you're not only connected to the video controller. Whenever you design a new video controller, you also actually have some sort of pixel streams in here, and an input stream and an output stream for the pixels. However, the CPU does not need to access this here. Actually, it doesn't interact with the pixels directly. What it does, it actually interacts with the core through that wrapping circuit. And another reminder, and actually makes things a lot easier compared to the MMIO controller, we only need to do decoding because the CPU only writes into the core, it doesn't read from it. So whenever we design something, we're gonna define these standard signals and we're just gonna do decoding. We're not gonna be doing any multiplexing. For the sake of consistency, I'm showing you in here that we will have a bypass control register at this particular address location, which is 2000 in hex. And the reason why is because no matter what you develop, whatever video core you develop, you will have some sort of a blending techniques, whatever blending technique you use. And the blender also allows you to bypass. Regardless of what you're doing, at least you should have some sort of a bypass mechanism, like basically completely bypass the functionality of this core so that whatever input you have, you'll basically map it directly, or you just route it directly to the output, and that's it. It's as if that particular core does not exist. So for the sake of consistency, we're gonna just designate this particular address to be a 1-bit control register. If you set it to 1, you're bypassing it. If you're bypassing this core. If you set it to 0, you're not bypassing that core. You can basically, the blender functionality, whether you're doing alpha blending or any of the other blending, you can actually map it wherever you want in that control register. Another improvement, or actually another design consideration that we did here, it's not necessarily an improvement, is in here we had a frame counter in the pixel generation circuit. So what we did in here, instead of having that frame counter inside the core, we moved it outside the core and we called it global. So all 8 cores that we are about to design can share that frame counter, so they will have the same exact X and Y, all of them, so that they can actually function this way. This, again, remember, the video subsystem is an example of a sort of a stream processing interface, and this will be a centralized flow control. So that will basically control the flow across all of the cores. If for some reason or another, because you have one core is functioning at a speed that is much faster than the other, or one that actually operates at maybe using burst, and you need some sort of a not centralized, you need something more of a distributed flow control, you can actually move that particular local frame counter internally to the core architecture or to the video core, and you add a FIFO internally too. The rest actually is exactly the same. The wrapping circuit and everything else is exactly the same. It'll have the same exact standard signals as well.